Hello students, welcome back to the fifth video of this playlist. In this video, we will be solving question number 5 from the recent past paper of Pure Mathematics 2, which is the May 2024 P2 paper. So let's get started with question number 5. At first, part A, here the question says given that x and y are positive numbers such that x minus y whole cube greater than x cube minus y cube. Prove that y greater than x. Okay, we need to prove that y greater than x. Okay, so for part A, at first let's simplify this given inequality. So to simplify it, what we will do is that we will expand the bracket, that is, we will expand the cube. Okay, so if you do so, you will get a cube minus 3a squared b plus 3ab squared minus b cube. It is greater than x cube minus y cube. Fine. So what we can do now, we can take the terms x cube minus y cube to the left. If you do so, what you will get, x cube minus 3x squared y plus 3xy squared negative y cube negative x cube plus y cube greater than 0. Okay, so x cube cancels out, y cube cancels out. So we will have 3xy squared negative 3x squared y greater than 0. So from there we can take 3xy common. If we do so, we will have y minus x greater than 0. Okay, so we got 3xy times y minus x greater than 0. Okay, now how can we approach the final proof, our conclusion that y greater than x? Okay, have a look on this inequality. We can say that here x and y are both positive, right? Both positive, and left hand side is greater than 0. That is positive. Greater than 0 means positive. Okay, positive. So since the left hand side is greater than 0, therefore hence x must be greater than x, because hence y must be y, because if y is not greater than x, then y minus x will give negative value and the inequality will be false, isn't it? So that means y must be greater than x. Therefore it is proven y greater than x. That okay, y greater than x. That's it. Fine. That's what part A of question number 5 has asked for. Fine. Okay, next is part B. So in part B, the question is asking to use a counterexample to show that the result in part A is not true for all real numbers. Okay, the result in part A, it is that x and y are positive numbers such that x minus y whole cube greater than x cube minus y cube, and we have proved that it is this inequality is true for y greater than x. So what we will do is that we will consider two values, one for x and another one for y, in such a way that it will be just opposite of the given inequality. And using that opposite inequality, we will show that we are still getting this inequality true. Okay, so it says y greater than x, so we will consider y less than x. Okay, y less than x. So let's consider two values for y and x. Let's say x is 3, y is -1. Okay, for part B we can say x equals to 3. You can consider any value. X is 3, but only x should be greater than y. Consider that inequality. It should be opposite, counter. Okay, so x is 3. We are considering x 3. Y equals to -2, let's say. Okay, so now consider the inequality x minus y whole cube. So x minus y whole cube, that is basically 3 plus 2 whole cube. This is giving 125. Okay, and the right hand side of the inequality, it is x cube minus y cube. So x cube minus y cube, that would give you 27 minus 8, so which is plus 8. So 27 plus 8, it is 35, which is less than 125. So basically x cube minus y cube, it is less than x minus y whole cube, right? So x minus y whole cube, it's what? It's greater than x cube minus y cube when x is greater than y. When x is greater than y. But here the question in part A, we showed the result as y greater than x. But now using x greater than y, we showed that the given inequality, it is also true. Okay, hence proven. The result the result in part A is not true for all real numbers. That's it. That's what part B of question number 5 has asked for. Fine.